All right, this will be a quick one because we're only dealing with 5 winds and there's not a lot of slides with it. And rather than looking at the massive thousands of square mile patterns that we see in the global ones, there's some local variations that will create different patterns of wind that may make an area cooler or warmer, or different conditions with humidity depending on what's going on. And 2 of these affect us directly, one of which is the land sea breezes. So during the day, land heats and cools faster than water, so the land warms up. So that warm air rises, creates low pressure. The ocean is relatively cooler, and so that air descends, creating an area of high pressure. The air moves from the high to the low, so mid-afternoon you get the sea breeze. And that sea breeze brings the cool air off the ocean onto land. How many times you've been at the beach, mid-afternoon, all of a sudden this really refreshing cool air comes off the ocean and drives down the local temperatures. These are very nice during the summertime in Southern California. They're quite noticeable in Southern California too, because we have a cold ocean current, so it really accentuates that difference in our sea breeze locally. At night, well, land cools faster, so it gets colder, so that air descends, creating high pressure. The sea is relatively warmer because it didn't cool off as much, and so we end up with air rising here. So we have high pressure, air moves from the high to the low, and you get the offshore breeze in the morning. This isn't as noticeable for us simply because our ocean water is a little bit cooler. On the East Coast, it is noticeable because they have a warm current. So our land sea breeze is predominantly the afternoon sea breeze. We don't get these locally. We don't have that huge elevation difference and the large valleys. So this is something you would see in the Rockies and the Sierra Nevadas, where you'd get the mountain and valley breezes. So during the day, the warm air the sun is heating the higher elevations. And so with the lack of vegetation, the exposed rock, they tend to heat up quite quickly. They absorb a lot of that energy and get very warm. So that air rises, creating low, and the cooler air will be drawn up to the higher elevations. Sorry, I misspoke. The valley air, the warm air, will be drawn up, and so you'll get an up valley breeze. That one's not as strong as usually what happens at night. At night, the mountains lose their heat very, very quickly, so they get very, very cold, and you get lots of descending air because they get so cold. That cold air sinks, and it will sink to the bottom of the valley and blow down valley. There are multiple locations that have to have some type of wind barrier upstream, and that's my phone ringing. I think I was talking about having some type of device upstream. So what you'll have is up valley from either your building, your tent, whatever. You want to have something that blocks that down valley flow of air. These can be substantial. Katabatic winds are similar, where you've got cold air at high elevations, and you've got to have, this is kind of a much larger scale of the nighttime valley breezes. So someplace like Antarctica, the Tibetan Plateau, the upper Rockies going into Canada, where you've got a huge, large, high elevation area that gets really, really cold, creating a lot of high pressure, and then that high pressure air flows away from that. Those are the katabatic winds. They're extreme, obviously, in Antarctica because of its elevation, its latitude. I mean, it's about as high a latitude as you get at 90 degrees south. The South Pole's over 10,000 feet in elevation, so it's extremely cold, lots of descending air. And for years, explorers didn't land on Antarctica because they couldn't, because the katabatic winds were pushing them away from the coastline. They could land on the peninsula with sailing ships, but it wasn't until you got powered vessels where they could actually get closer to the shore. There are areas in Antarctica that are snow-free because the katabatic winds are so strong, they just blow all the snow away in those areas. And then in the Pacific Northwest, as you get up into southern Alaska and up northern British Columbia, those become very substantial too. There's actually areas where the indigenous populations had their villages on the coast, which is unusual because you're exposing yourself to storms from the sea. your normal pattern for settlement would to be in the valley. So when the British came along, they thought the Native Americans were naive, and so they're like, that's a stupid place to build. So they would build in through here, where the locals knew that that was a bad place, because in the wintertime there'd be extreme cold air coming down right through where the English settlements were. Okay, obviously we get the Santa Ana winds. So these tend to develop in the fall. It's not always going to be that way. We've had pretty severe Santa Ana winds in February in the past, but you'll get a little bit of high pressure that kind of pinches off, and it'll stay over the Great Basin, which is Nevada, and it stays there because the westerlies have shifted to the north, and so they're not really pushing it away, and we get a little band of low pressure off our shore, and so that air moves from the high to the low in creating the winds. Now, there's lots of places where this happens, but what's special about the Santa Ana winds is that the elevation change combined with what this is like. Think about it. This is a desert in through here, so this air is going to start off warm and dry, but when air goes from a higher elevation to a lower elevation, which we'll talk about more later, but when air goes from high elevation to low elevation, it gets warmer. And also when the air gets warmer, it gets drier. So we're going to start off with warm, dry air and make it warmer and drier. And as it comes into Southern California, there's only a couple places where it can get through the mountains. And so we're concentrating the movement of air through very narrow passageways. So therefore, it's going to speed it up because you've got to get that air moving through the volume of air, but you've restricted its pathway. Picture you've got the hose in the backyard and you put your thumb over the end of it. What happens to the speed of the water coming out of the hose? It accelerates it. And so by concentrating the wind through those narrow valleys, the winds can speed up tremendously. So this is our local condition, which I love. I grew up in North Orange County, where the Santa Ana winds are really noticeable because it would come out through the Santa Ana Canyon, kind of the path that the 91 freeway takes, and it would shoot right across Fullerton, where I lived. And these were dramatic. Trees would blow over, RVs would blow over. They were kind of fun as a kid. I miss them now that I'm down in South Orange County because they're not quite as dramatic. It's dry, it's windy, but it's not the same. 2007, you can see all the fires. So this is where the high pressure is. Air moves from the high to the low, and then the fires are conveniently marking the path that the wind is blowing towards. Now notice the clouds kind of stop over here. Well, this is where the low is, and so there's no pressure gradient. So the air moved from here through this, made it really, really dry, which accelerated the fires, and into here where the low pressure is. So the monsoons, those are the wind systems that hit South Asia and to some extent Southeast Asia. And the ITCZ shifts north and south. So all the air moves into the ITCZ. So in the summertime, when the ITCZ shifts to the north, the air moving into the ITCZ from the south is coming off the Indian Ocean, which is a warm, wet air coming off the Indian Ocean. So it brings a lot of moisture into India. In the winter time, the ITCZ shifts to the south, so the winter monsoons, this is not moist at all. These high elevations are dry, and so therefore it brings dry air. So in South Asia, the monsoons bring the rain in the summertime and bring the drought in the wintertime. The monsoons are not the rain. The monsoon are the winds. They just simply bring the rain or they don't bring the rain, depending on the time of year. Unfortunately, in Arizona, they call it the monsoon season when the thunderstorms move in, and a lot of people get confused thinking monsoons are rain. And it's like the monsoons bring the rains. They bring heavy rain, but they're not the rains. The monsoons are the winds. So that was it for our local winds. When we come back, we'll do the properties of water, evaporation, condensation, all sorts of fun things. All right. See you later.